Okay, just got off the phone with my mom, back to programming. Right, include IO stream. It says, write a program that prompts the user to enter two integer values. Store these values in int variables named val1 and val2. Write your program to determine the smaller, larger sum, difference, product, and ratio of these values and report them to the user. Okay. So int main cout. Please enter two integers. And int val1, int val2. Cout. Let's see, if val1 greater than val2, cout the first integer is larger than the second. Else if val2 greater than val1, cout the second integer is larger than the first, else cout the integers are equal in value. Okay. Determine the sum. Okay, cout val1. The sum of the integers is val1 plus val2. Cout the difference of the integers is val1 minus val2. Cout the product of the integers is val1 times val2. Cout and the ratio of the integers is val1 divided by val2. And we'll just call this exercise 1.c++. Why not? It's clear. G++-O 1 times C. Cout was not declared in this scope. Yep, that's because I forgot to use a namespace. Standard. Okay, it runs, or it compiles, I should say. Now let's run it. Let's see, 1 and 2. The second integer is larger than the first. The sum of the integers is 3. The difference of the integers is -1. The product of the integers is 2. The ratio of the integers is 0. And that makes sense because when you take an integer and you divide it by another integer, when you take 1 and you divide it by 2, 2 goes into 1 0 times, so it's doing integer division. I wonder if I typecast one of these to a double, if I'm going to get something different here. Yeah, so right here I did a little typecast. I typecast this val1 to a double, and so when you divide a double by an integer, it promotes the integer to a double and then does the division, and therefore I get a 0.5. So that makes perfect sense. So that exercise is down. Modify the program above to ask the user to enter floating point values and store them in double variables. Okay. Compare the outputs of the two programs for some inputs of your choice. Are the results the same they should be? Should they be, and what's the difference? Well, let's see here. The results are going to be different because we're doing division with doubles, not integers now, and so we're not going to lose the decimal part of the computation. So x1.c++. So if I enter 2.6 and 3.5, it will say the second integer is larger than the first. The sum of the integers is 6.1. The difference of the integers is 0.09. The product of the integers is 9.1. And the ratio of the integers is 0.742857. Yeah, so that's different output using doubles versus integers. So it asks me what's the difference. The difference is a program that accepts only ints can only do integer division, and we lose the decimal part of the computation. So that's exercise 5 down. Okay. Let's go to exercise 6. Write a program that prompts the user to enter 3 integer values. Okay. Include standard IO. IO stream. Getting my C and my C++ mixed up. Using namespace standard main. Cout. Please enter 3 integers. Int 1, int 2, int 3, cn 1, 2, 3. And then outputs the values in numerical sequence separated by commas. So if the user enters the values 10, 4, 6, the output should be 4, 6, and 10. If two values are the same, they should just be ordered together. So the input 454 should give 445. This is a bit of a head scratcher. Okay. So we want to print out these three integers in ascending order. I'm going to need a smoke here to contemplate how to do this. It seems like a trivial challenge on the surface, but I'm not getting any ideas right off the bat. Let's see, if 1 less than 2 and 2 less than 3, C out 1. Two. Exercise 2.c++. Let's see, if 3 less than 2 and 2 less than 3, let's see. This is getting complicated. There's got to be a better way to do this. It's just sorting three numbers, right? Which should be pretty damn simple, but do I really want to write a bunch of if statements? Technically, it's the only logical structure we've been introduced to so far in the book, so, you know, if this was a real-life situation, I would just store them in a vector and sort the vector with a binary sort or something, you know? Well, I'm going to be a bad student and say this exercise stumped me, so I'll put an X there. And the next exercise, it says, do exercise 6, but with 3 string values. Yeah, I'm going to be stumped on that one too, so I'm just going to move on. So one of the things I learned in college is that if you're presented a problem and you don't have any initial idea about how to solve it, and you sit around for maybe 2 or 3 minutes and it's still not apparent how you should go about solving it, you should just move on, right? So instead of getting stuck on this one thing for like 2 or 3 hours, and I could go out to the internet to look up the answer, but I don't want to do that. I'm going to let these problems stew in my mind, right? You know, how do I sort 3 numbers when I only have access to if statements and I don't have a vector, you know? So that'll just play on my mind in the background, and maybe that's something I'll come back to. Okay. Next problem, problem number 8. Write a program to test an integer value to determine if it's odd or even. As always, make sure your output is clear and complete. In other words, don't just print yes or no. Your output should stand alone, like the value 4 is an even number. Hence, see the remainder modulator operator in 2.4. This is something I actually know how to do. So let's do it. Include IO stream. And using namespace standard int main blah 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 blah. All right, see out. Please enter an integer int test cn test cout. Let's see, if test modulus 2 equals 0, then cout the value test is an even number, else cout the value test is an odd number. So if the remainder, if you divide by 2 and your remainder is 0, you have a even number. So I'll just call this eo.c++. g++ eo.exe, oh, dash o eo.exe, eo.c++. Whoop, forgot a semicolon. Thanks, compiler. Alright, eo, please enter an integer like 8, value 8 is even, please enter an integer 3, the value of 3 is odd. Alright, I did that. Write a program that converts spelled out numbers such as 0 and 2 into digits, such as 0 and 2. When the user inputs a number, the program should print out the corresponding digit. Do it for the values 0, 1, 2, 3, and 4, and write out not a number if the user enters something that doesn't correspond, such as stupid computer. What? Let's see. Okay. Let's do it. Include IO stream using namespace standard int main so cout enter a digit using words. Okay, so int input if let's see, I need a string now. So string input, cn input, if input equals 0, cout 0, one, cout 1, equals 2, cout 2, this is exercise 9, right? ex9.c++, okay. Clear g++ dash o exercise 9.exe exercise 9.c++. Oh, compiler errors. My goodness. Look at all this. Look at all this. Let's see, include string. I misspelled string as sting. I will change that and recompile. Let's see, we still get compiler errors. Let's see. Okay, let's clean up that error. There we go. Let's go. Okay, so if I enter 4, it prints out 4. Okay. Oh, there's another. Let's see. Else. 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 Okay, let's recompile. Enter a digit 0 through 4 using words. Okay, so let's try 3. That works. Let's try stupid computer. Not a number I know. Okay, let's try 9. That's not a number I know. Okay, that's exercise 9 down. Let's see, exercise 10. Write a program that takes an operation followed by 2 operands and outputs the result. For example, plus 100, 3.14 times 4.5. Read the operation into a string called operation and use an if statement to figure out which operation the user wants. For example, if operation equals plus, read the operands into variables of type double. Implement this for operations called plus, minus, times, divide, plus, minus, mul, and div with their obvious meanings. Okay, so we're getting a little more intense now. let's include iostream using namespace standard main. So string, let's see, include string, so string operation. Let's see, cout, enter an operation followed by 2 floating point numbers. Alright, so cin operation double operand 1 double operand 2 so we read everything in. If operation equals plus or operation equals plus cout operand 1 plus operand 2. If the operation equals multiply or operation equals mul cout. Let's put a new line in there just because operand 1 times operand 2 let's see, if operation equal divide or operation div plus, let's see, I forgot about minus. If operation equals minus or operation equals to minus so this is exercise 10 G++ -o x10.exe x10.c++. Missing something here and right parentheses, okay. Line 21. Oh. There we go. Exercise 10.exe. So if we do times 10, 9, we get 90. If we do divide 9, 10, we get 0.9. Alright. If we do add 4, 5, Oh, it's plus. Okay. Plus 4, 5. We get 9. All right. If we do div 8, 4, we get 2. Let's do div 9, 7. Yeah, okay. Okay, that's exercise 10 done. Exercise 11. So this is the last exercise of the chapter. So I'm assuming it's a little more involved. Write a program that prompts the user to enter some number of pennies, 1-cent coins, nickels, 5-cent coins, dimes, 10-cent coins, quarters, 25-cent coins, half dollars, 50-cent coins, and $1 coins, 100-cent coins. Query the user separately for the number of each size coin, e.g. how many pennies do you have? Then your program should print out something like this. You have 23 pennies, you have 17 nickels, 14 dimes, 7 quarters, 3 half dollars. The value of all your coins is 573 cents. Make some improvements. If only one of a coin is reported, make the output grammatically correct, e.g. 14 dimes and 1 dime, but not 1 dimes. Also report the sum in dollars and cents, i.e. 0.73 instead of 573 cents. Okay, I think I can do this. Include IO stream using namespace standard main. Okay, see out how many pennies do you have? See out how many nickels do you have? Whoops, I need to accept user input here, nickels. See out how many dimes do you have? And I see a mistake here. Yep. And here. And here. How many half dollars? Okay, let's save this exercise 11.c++. Let's just make sure it compiles now. G++. Dash O example 11.exe example 11.c++. See, quarters was not declared in this scope. So let's look. That's right. Into quarters. Alright. It's clear. How many pennies do we have? Let's say 1. How many nickels? 5. Dimes 2. Quarters 5. Half dollars 3. Let's say 3 again.
This is a cool game.
Okay. So that's that.
Are you streaming?
Yeah. I'm recording for YouTube.
Hello, YouTube.
YouTube says, hi, Devin. Now let's see, to compute. So, C out. The value of all your coins is pennies plus nickels times 5 plus dimes times 10 plus quarters times 25 plus half dollars times 50 plus dollars times 100. Let's see. So we can test to see if this example is correct because we have the expected output here. So let's do that. Clear. Recompile. There's lemon. Okay, so 23 pennies, 17 nickels, 14 dimes, 7 quarters, 3 half dollars, and 0 full dollars. The value of all your coins is 573 cents. The value of all your coins is 573. Okay, so I did that correctly. Let's do cents. Clean up the output a little bit. So we do the same thing. 23, 17, 14, 7, 3, 0. Alright. It says make some improvements. If only one of a coin is reported, make the output grammatically correct. For example, 14 dimes and 1 dime, not 1 dimes. Also report the sum in dollars and cents. So this is a bad idea, but I'm going to skip one part of this exercise. I'm just going to report divided by 100. So 573 cents is $5.73, right? So let's check that. Okay, 23, 17, 14, 7, 3, 0. The value of all your coins is 5 cents. Okay, something went horribly wrong here. I think my order of operations, maybe. Oh, it's doing integer division. Right. Okay. Well, I know how to fix that. Yep, integer division will bite you in the ass sometimes. Yay! $5.73. Let's improve the output a bit. Put a dollar sign here. And get rid of that. Recompile. Retest. There we go. 573 cents is indeed $5.73. So that's exercise 11 down. And we'll read this postscript. Please don't underestimate the importance of the notion of type safety. Types are at the center of most notions of correct programs, and some of the most effective techniques for constructing programs rely on the design and use of types, as you'll see in Chapter 5 and 8, and indeed most of the rest of this book. Okay, so I'll just put a little box around that. You know, that's important information. We're on to Chapter 3, but I'm going to take a break now.